Hi, today I'm going to be taking a look at the EBL USB-C power supply. It's a pretty interesting unit. It's got, let me just get a focus going here. It's got two USB-C and two USB-A ports. Plus, it's kind of like a power strip. It's got one receptacle here, another receptacle here. Packaging is pretty plain. I'm not going to go into that, but this is the outer box, and it's basically the spec sheet. So I'm not going to test every single one of these. I'm just going to test a few of them to get a feel for how this power supply works. So I've built a load tester. This is just a bunch of resistors. It's not really the best way to test these power supplies, but it's what I came up with. And it has a little USB-C trigger board. So this will basically simulate a USB-C device. So it tells the power supply to give a particular voltage, and then that will be passed along to the bank of resistors I have here. So we're driving 5 volts and 1 amp, so 5 watts. And with the trigger board, I can switch that to 9 volts, 12 volts, 15 volts, and 20 volts, or in this case it's 19, which is within specification. And you can see we're actually have 70 watts, which is more than the 65 watt rating. And that's okay. Most of these power supplies from various brands will drive a little bit more than the specification. They're kind of overbuilt a little bit, but I can actually try to overdrive it even more. Right now with this set of resistors, they're connected in a particular configuration, and I have a switch to change that configuration, which will overdrive it. So you can see here, it dropped down to 15 volts. So the power supply understood that it was drawing too much current and went down to a lower voltage, so it would be too much power drawn. And then if I flick this switch again, see, it goes right back up to 19 volts. So that's working as expected. And that's on the first USB-C port. Okay, so let's go through this on the second USB-C port, excuse me, 9 volts, 12 volts, 15 volts, 20 volts, and I'm expecting this to drop back down to 15 volts, and it does. So I have this mess here, which is not the way you should be testing this, but I just wanted to make it so you could see the screen in the right orientation easily. Otherwise it's upside down. So it's another power meter. This one's for USB-A. Hopefully that screen comes out there. And then attached to that, it's another set of resistors. It's just 2 resistors. It's a very simple way to test. And then some switches to turn either one resistor on, the other resistor on, or both resistors. So let's do that. So we've got 5 volts and 1 amp, so that's 5 watts, 2.2 amps, so that's 11.6 watts, and then 3.3 amps, so that's 17 watts. So we're definitely going over 15 watts, which is what I expected. I don't actually have a way to test the 20 watt claim. You need a phone that does the, well, what do they call it? QuickTime? No, not QuickTime. Quick Charge. QC for Qualcomm. Quick Charge or Huawei or any of those brands that have a non-USB-C power delivery high power mode for USB-A. So I don't have those devices. This is the lower power USB-C A port. I'm going to drive it to 1 amp. That's working fine. I'm going to turn that off. Try to drive it to 2 amps. Doesn't like it. Just immediately shuts off. Nothing's happening. That's good behavior for port shutdown. Let's overdrive it to 3 amps. Nothing. Doesn't like it. And then we can immediately come back and get 1 amp. So the port shuts down. That's the behavior I would expect. Okay, but if we go back to the spec sheet, we have all these different combinations. So for me, the most important combination for any of these power supplies that have more than one port is I'm going to have a laptop and I'm going to have a phone. I've got 15 watts going to, well, these resistors. And let's see how high I can go. Whoops. I'm going to do my trigger board here. $12 volts, 15 volts. Let's see if we can make it to 20 volts. Doesn't like it, drops down. So I think this behavior is expected. If I go look back at the spec sheet, it won't, because of the particular load I'm using here, I can't actually get to 20 volts because that would drive too much power. And so it's behaving the way it should, I think. Now, that's with 15 watts on the USB. Let's see if I just drop that down to 5 watts. So let me just zoom in again. So we have 5 watts on USB-A, and I'm going to try to drive the USB-C up. 15. Still doesn't like it. Okay. Okay, let's try something else. We're up to 70 watts, which is what you'd have for a larger laptop. And now I'm going to plug in my phone, my simulated phone. Okay, so the screen turned off. And that's actually something I expected. And it's something that happens with most of the USB-C power supplies that have multiple ports. And what's happening is the power supply is distributing power to the different loads basically according to the spec sheet. And it won't be able to drive the maximum load on as it did. 5 watts isn't really what the laptop would be doing. It would be renegotiating back up to that higher wattage. So let's go ahead and do that. And whoops, I just disconnected it over here. Hold on. Did it again. Okay, let's renegotiate as the laptop would. So again, we have our phone charging, and the laptop's going to attempt, and it can't do it. It can't get back to 20 volts, well, on this particular load, because of this table. The power supply is distributing the power as it deems appropriate. So that's expected behavior. Okay, so we have 2 devices plugged in. What about if we plug a 3rd device? Let's just plug in another fan here. Okay, this one's probably taking another 3.5 watts. But we have all 4 devices working. Oh, whoops, I did something. Yep, they're all working. 45 watts on the laptop, 12 watts on the phone, and we have our 2 fans at 3.5 watts each. Okay, I've left 2 laptops plugged in charging. Ambient temperatures around 13 degrees. And if we go to the power supply, there's a hot spot I found somewhere. So it's running a little warm. It's not terrible, but a little warmer than I'd like. But I mean, I can touch it. I can hold it. It's okay. And we can do that unplugging, and it'll renegotiate the power, so it drops off for a second and comes back. This bottom port, USB-C bottom port, charges at a slower rate than the top port when both are plugged in. The top port will default to 45 watts, and the bottom will default to 15 to 20 watts, which is within spec as well. So here I'm going to test efficiency. So I just have this cheap wall socket power meter. So it reads 0 with nothing plugged in. Once I plug in the power supply, we can see it 0.2, 0.3 watts. So that's like a parasitic draw. So it's always going to use a tiny little bit of power. This is typical of most of these kind of power supplies. It's not bad. It's not ideally you'd have it use 0. There's very few power supplies you can get that will do that. I mean, you can have one that has a switch on it, which is kind of what I would prefer actually, but hard to find those. So let's see how the efficiency maps to different power loads. So what I would expect with a power supply like this is that it would be inefficient at low loads. So here we have 5 watts going out and 6.6 watts. So you could say that 1.6 watts are being wasted. As a percentage of that 5 watts, that's a tremendous amount, percentage lost. The actual loss is very small. As we go up in power, let's go to 16 watts. So 16 watts versus 18 watts. So now the actual amount being wasted is higher, so it's 2.5 watts, but as a percentage of the power that's being used, the percentage is lower. So it's becoming more efficient as we go into higher power modes. So now we're at, let me just zoom in a little bit. So now we're at 28 watts versus 31. Again, more power is being kind of going into thin air, going to heat basically, but the efficiency is increasing. Let me get to 45 watts, 40. I'll make a table so we can actually see how this efficiency curve pans out. And then we're going to go into that overdrive mode of 70 watts. And then we have, so the worst case, we have 70 watts versus 76 watts, so about 6 watts lost. Again, I'll calculate those as a percentage, but you can kind of see the behavior. And this is typical with any of these kind of 65 watt class power supplies. They're going to be horribly inefficient at 5 watts, which is a very small load, but will gain efficiency as you draw more. And this is on the USB-C port. Let's do the same for the one of the USB-A ports. I would expect similar behavior. And even just plugging that in, for some reason, we're drawing half a watt. Let me unplug it. Oh, there's LEDs on, so maybe that's why. Just unplug that, make sure. Okay, so I mean, it's fluctuating between 0.2, 0.4, that's fine. Okay, let's plug that in again. Oops. Okay. So hopefully I can get both of these on screen at the same time. So we're going to go up to 5 watts. So we're at 5.5 watts on the USB power meter versus 6.7 watts. I think that's a little more efficient than what we saw on the USB-C. I'll have to double check. And then we're going to go up to 11.5 watts versus 13.6. And finally, 16.8 watts versus 20. So it's not terrible. It's, I mean, kind of what I would expect. Not the best, not the worst. But yeah, there's the efficiency. Okay, I've got a new setup here. I've got an old oscilloscope here and a multimeter. So we're just going to do some voltage testing. There's the power supply, and then I have oscilloscope probes. That's the probes I'm going to use for testing USB-C A. And then I have probes over here. Don't do this at home. This is not a safe setup. This is just really temporary. But it's the best I have right now in my workshop. Yeah, 5 volts per division. So when I unplug it, I'll go back down to 0. I plug it in, it goes up 1 division, so that's 5 volts per division. Okay. Now, if and this is just for fun, this is not the testing I really want to do, but we can see it go up to 9 volts, 12 volts, what are we doing, 15 volts, and then it'll probably go off the screen, 20 volts. You can barely see it there, and then back down to 5. Okay, but that's not the part we're really interested in. We're interested in the AC components. So this is going to go back down to 0, and what we're going to do is zoom in. Well, effectively, we're zooming in. And the closer we zoom in, we can see this noise. And no power supply is going to have perfect voltage. There's going to be some disruption. And you can actually calculate it using the settings on the oscilloscope. We have a time index here, and it's saying that every division this way, horizontally, is 2 microseconds. So, 1, 2, 3, something like 300 kilohertz, I think. So there's a switching mechanism inside here, electrical circuit, that's switching at 300,000 times a second. And the artifact of that is this waveform, which is tiny. Again, if we go back to DC, that's our 5 volts. So we have to zoom in pretty far to see that. So now we're at 0.2 volts per division. So 0.2 volts is only up to here. And now we're at 20 millivolts per division. So peak to peak is the kind of standard way you want to measure. So this peak, approximately 2 divisions. So we have 40 millivolts peak to peak ripple in our voltage going to whatever we're powering. And this is at, I'll just bring the power supply up here. This is at 5 watts, 5 volts, 5 watts. Now watch what happens when I press the trigger button. We're going to go to a different power mode. So now we're charging at 16 watts. And I haven't changed anything on the scope. All I've done is change what the power supply is doing. And there's more noise. And so I'm going to, just so it's easier to measure, it looks like it's 3 divisions, whereas before it was 2. So that's 60 millivolts. I'll switch it again. It's a little bit higher on the 12 volt setting, so we're charging at 28 watts. That looks a little different at 15 volts, but not a huge amount. 5 millivolts peak to peak, and then up to 20. I don't know why that changed so much. Like the waveform looks completely different. Okay, well, there's a lot more noise going on there. At 20, I'm not quite sure what's happening here. See, there's those spikes. So there's definitely something, there's like multiple frequencies. We really need a spectrum analyzer to understand this better. But we do have that main frequency of 300 kilohertz and then some other frequencies. But if we go back to the same measurements we were on before, the total noise is definitely higher when we're charging at this higher rating. What is it exactly? I'm not sure. There we have USB-A. So we're at 20 millivolts per division. So about 40 millivolts at 5 volts. And then that's in 1 amp. So hold on, let me just get this in frame here. That's 1 amp, so 5 watts. Now we're turning up to 7 watts. So once you turn up the power, there's definitely more noise, not a significant amount. But now we're somewhere, I don't know, is that 50 millivolts total? I don't know if this is good or bad. This is my first time doing this kind of testing on a power supply, well, at least in this century. But there's my results. So what do I think of this EBL power supply? I think it's pretty good, aside from getting a little warm, and some of those noise issues, which again, I don't know if that's really bad. It might be fine. There's really no guidance from USB.org on what level of that voltage ripple is acceptable or not. They kind of just say if you're trying to target 20 volts, then anywhere between 19.5 or 19.0 and 20.5 is fine. It's not particularly helpful, but it does concern me a little bit that in that 20 volt high charging mode there is significantly more voltage ripple than in the lower modes, but lower power settings. But I guess that's to be expected with any power supply, so I'm gonna have to look into that a little more. Otherwise, the functionality is there, all the ports work. Again, this spec sheet, it's not that it's complicated, it's just that there's a lot of, because there's 4 ports, there's a lot of different ways you can connect devices, and sometimes, if you're plugging your laptop in and it's happily charging away at 65 watts, and then you plug in a cell phone, it's probably going to drop down to 45 watts. Some other brands will drop down, but maybe it'll drop to 60 watts, and then it'll still allow your phone to charge. So what I'm saying here is basically if you plug anything else in, you're not going to get that high charging mode. Is going to drop down to somewhere around 45 watts, at least with my test setup. With another test setup, again, I'm very limited in what I can do here. I can't test all of these combinations, but you're not going to get the full charging rate on your laptop when you plug something else in. Again, that's expected. That's how other power supplies work as well. Otherwise, the kind of bonus feature of having these 2 power receptacles, it's nice to have. It's not something that that I would use, but I can see this being really helpful for some people's setups. The power cord is permanently attached. I prefer it to be the type where you can disconnect. I think it's IEC 7, the type that would plug into the back of a desktop PC. So that would be an interesting improvement. The cord itself is capable. It's thick. Yeah, I'm not going to cut it open. I kind of want to keep this actually. But the cable is about, I don't know, a meter long. So you could snake it behind your desk and then have this power supply sitting on your desk to power all your devices. And the it's not really that big. Let's see. I think I have. Let me just hold on. Let me get that in focus a little better. So let's just measure it here real quick. So this part of it is, you can see that 102 millimeters by 47 millimeters by what is that, 36 and a half. So it's pretty compact. It's a relatively soft plastic. I don't think it's really going to scratch your desk or anything. It's not particularly high end. It's not low end either. It's just, it's fine. Yeah, so I like it. I'll use it. And I'm just going to look into those noise voltage ripple stuff. And oh, let's look at the label on the back here. So I'm not sure what these ratings mean. I don't see a UL symbol. I'm gonna have to look up. Usually top rated manufacturers will have a lot of symbols on here indicating certification organizations. Let me get another example. Top name brands or anything. So here's one that's more of a name brand. This one's Energy. So I don't know if that really comes out on camera very well, but there's more stuff on there. I'm not an expert on what all these symbols mean, but there's more stuff. And I guess that's good. I don't know. Here is an Apple one. Actually, Apple's supposed to have some of the best power supplies, but this is one of the really small ones, so I don't know if this is a good example. It definitely has it definitely has the UL symbol right there, Underwriters Laboratories, I think. That's usually the one I look for, or CSA, Canadian Standards Association, something like that. So Apple's better, I guess. I don't know. Anyway, that's what I found. Thank you for watching.